Rahim. Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the book Modern Physics by Kenneth S. Crane. Dear students, our previous problem was also to some extent related to this problem. Okay. Previous problem was also about cutoff wavelength, and this problem is also regarding cutoff wavelength. However, in this problem we have to find out stopping potential. Okay, as usual we first come towards its statement. Okay, a metal surface has a photoelectric cutoff wavelength of 325.6 nanometer. Nano means 10 to power minus 9 meter. Okay, it is illuminated with light of wavelength 259.8 nanometer. Okay, here again nano meaning 10 raised to the power minus 9. Dear students, here it is important to point out here that one wavelength is cutoff wavelength while the other wavelength is not cutoff. Okay, we will see its detail when we solve this problem. Okay, what is the stopping potential? In previous problem, new term introduced was cutoff wavelength. Okay, and we had not discussed this term in detail. However, we had expressed its mathematical expression just to solve the problem. Okay, in some subsequent video we will talk on this term more comprehensively. Okay, similarly in this problem the newly introduced term is stopping potential. We know that potential is usually denoted by capital V because it is stopping potential. So we will denote stopping potential by Vs, where S will be written as a subscript of capital V. Okay, anyhow we move to our solution, and before starting our solution we come to helping tools. Okay, so first helping tool is this table, which has already been used many times. In this table not only speed of light is given but also Planck's constant h is given in two different patterns or systems. Okay, tool number 2. In this tool has been shown just to ensure that symbol used for work function is phi. Okay, this phi. Okay, 1 2 3 4 5. Okay, row number fifth row in third column. Okay, phi, phi, this is the work function. Okay, similar is psi, but psi notation is different from this. Now we come to its solution. Okay, we know that work function phi is given as phi is equal to hc over lambda c. Okay, dear students, we have dealt with this expression in our previous problem or previous video. In that video we have, in that problem or in that video we had to find out cutoff wavelength. The only difference was that cutoff wavelength was in place of work function phi, and work function phi was in place of cutoff wavelength lambda c. C is written as a subscript of lambda. Okay, so this is just an arrangement. Okay, so here in this problem we have once again used all the three values. Out of these three values, two values have been chosen from helping tool. Okay, a helping tool in which not only the speed of light is given but also value of h is given in two different patterns or two different systems of units. Okay, however the value cutoff wavelength lambda c is given in the statement. Okay, the only difference is that two values have been chosen from helping tool, while third value is given in the statement itself. So after simplifying this, while simplifying, a second will be cancelled out with second, meter will be cancelled out with meter, and we will be left with the value electron volt. Okay, 0.0381 into 10 raised to the power 2 electron volt. But we know that 10 to power 2 is 100, and when 100 will be multiplied with 0.381, then it will become 3.81. Okay, 3.81 electron volt. Both values are equal. Okay, 0.0381 into 10 to power 2 electron volt is also work function, and this has been alternatively written as equal to 3.81 electron volt. That is to say, we have eliminated power 10 raised to the power 2. Okay, now we know that maximum kinetic energy of photoelectrons is given by, this is a new expression. Okay, we know that maximum kinetic energy, which is denoted in this expression by K max, where max is written in as a subscript of K. Okay, K denotes kinetic energy, and max having been written as a subscript of K denotes maximum. Okay, so maximum kinetic energy K max is equal to E stopping into stopping potential Vs is equal to Hf, H Planck's constant, F frequency minus phi work function. Okay, is equal to Hc over lambda minus phi. What we have done, we know that frequency and wavelength are reciprocal of each other with the involvement of C. Okay, that is F is equal to C over lambda, and lambda is equal to C over F. Okay, anyhow, where Vs is the stopping potential. This implies that, okay, here we will not use the term K max, we will use its equivalent value E into Vs, E into stopping potential. Okay, so E into stopping potential Vs becomes equal to, again, H and C both values have been chosen from the toolkit. Okay, helping tool, and divided by lambda, other wavelength. We know that in the statement two wavelengths have been provided or given. Okay, one is the cutoff wavelength and other is the this wavelength which is being used here. Okay, minus psi not psi, phi. Okay, phi minus phi work function phi we have calculated above. Phi is equal to 3.81 phi is equal to 3.81 electron volt. So here in this expression, in place of work function phi, we will use its value, that is minus 3.81 electron volt over 1, because actually, dear students, we have written it in this form that Hc is in the denominator and wavelength lambda given in the statement is in the denominator. Because these two terms are in division form in the denominator and denominator, and minus work function psi has no denominator, so definitely when something has no denominator, it means it has denominator as 1. So we have written 1 from our own side. Okay, so what we will simply just simplify this expression. While simplifying this expression, second will be cancelled out with second. Okay, second will be cancelled out with the second, meter will be cancelled out with meter, okay, and hence we will get E into Vs, that is E into stopping potential becomes equal to 4.77 electron volt minus 3.81 electron volt. Both are electron volt, so both will be subtracted in a simple way, and it will result in 0.96 electron volt. This is equal to E into Vs, but we have to find out simply Vs. So E will be shifted on other side of equality, and here E, which is in the numerator, which will become denominator on the other side. Okay, so E will also be cancelled out with E, and we will get Vs equal to 0.96 volt. Okay, because E is cancelled from both sides, and Vs becomes equal to 0.96 volt. And this is the end of our problem. Till next problem, Allah Hafiz.